There's a truck on this planet so big, so heavy, and so destructive that not a single government on Earth will let it touch a public road. It's not banned because it's too big. It's not banned because it's too slow. It's banned because the entire road system you drive on every day was deliberately designed to keep it out. The bridges underneath you couldn't carry it. The asphalt couldn't support it. The lanes couldn't contain it. And if it ever rolled onto your highway, not in theory, but in reality, the road wouldn't last a single trip. This is the Caterpillar 797. Weight, 1.375 million pounds. Cost, $5 million. And every road system on Earth was engineered with one job in mind, making sure machines like this never touch the roads you drive. The question isn't whether it could drive on your highway. The question is what would happen in the first 30 seconds if it tried. Ask 10 people why mining trucks can't drive on highways, and you'll hear the same 3 answers. They're too wide. They're too tall. They block traffic. All true. All beside the point. Because if size were really the problem, we'd just close a lane. We do this every day for other oversized loads. Wind turbine blades that are 200 feet long. Pre-built houses being shipped to construction sites. Military equipment that can't fit on a single trailer. We close roads. We get permits. We put up wide load signs. And we move them. Slowly. Carefully. But we move them. So why can't we do the same with a mining truck? The answer is that size isn't the problem. Size is just the first problem. Everything about these machines, their weight, their dimensions, their tires, their brakes, even their fuel system, is designed for a world the public road system literally cannot exist within. These aren't oversized trucks. They're a completely different category of machine. And to understand why, we need to start with a law of physics most drivers have never heard of. Let's start with the numbers, because numbers are the only honest way to describe this thing. The Caterpillar 797F, the most used ultra-class mining truck in the world, weighs about 687,000 pounds when empty. Fully loaded with rock and ore, it tips the scales at 1.375 million pounds. For comparison, a fully loaded American 18-wheeler, the biggest truck you've ever seen on a highway, maxes out at 80,000 pounds. That's the legal limit set by U.S. federal highway regulation. That means one loaded mining truck weighs roughly 17 times more than the heaviest truck legally allowed on your highway. It's 23 feet tall, 49 feet long. Each one of its 6 tires is over 13 feet tall and weighs 11,000 pounds. You don't climb into the cab, you ascend a staircase. And the 797 isn't even the biggest. The Belaz 75-7010, built in Belarus, holds the world record. Fully loaded, it weighs over 1.78 million pounds, 22 times more than any standard highway truck. These are the largest land vehicles humans have ever built for daily commercial use, and not one of them is allowed on a public road, anywhere, on Earth. The reason isn't bureaucracy. It's a law of physics that highway engineers learned the hard way over 60 years ago. Here's something almost no driver knows. The damage a vehicle does to a road is not proportional to its weight. It's proportional to its weight, raised to the 4th power. This is called the 4th power law. It came from a massive road experiment conducted by the American Association of State Highway Officers in the late 1950s. Engineers drove trucks of different weights over identical test sections of pavement, over and over, until the pavement failed. And they discovered something terrifying. If you double the weight on an axle, you don't double the damage to the road. You multiply it by 16. Triple the weight, and the damage multiplies by 81. Engineers measure this using a unit called ESAL, equivalent single axle load. 1 ESAL equals the damage from a single 18,000-pound truck axle. That's the reference point. Basically, a normal truck axle. A single normal truck axle does over 3,000 times more damage to pavement than a single passenger car axle. 3,000 times from one normal truck compared to one car. Now plug in a Caterpillar 797. A loaded 797 has 2 axles. Each axle carries roughly 687,000 pounds on average. That's 38 times the standard axle load. Run that through the 4th power equation, and a single axle pass of a loaded mining truck does over 2 million times more damage to a road than a passenger car. 2 million. One drive across your local highway by one mining truck would inflict more pavement damage than the entire daily traffic of an average American city. The road wouldn't last a week. Some sections wouldn't last an hour. This isn't a theory. It's the math that every highway engineer in the world uses to design every road you drive on. The 80,000-pound legal limit isn't a random number. It's the maximum weight the system was designed to survive. Mining trucks don't exceed that limit. They render it meaningless. But the pavement isn't even the worst part. Bridges are. Every bridge in the country has a posted weight limit. The maximum legal weight on a U.S. interstate bridge is 80,000 pounds, calculated through something called the Federal Bridge Formula. Smaller rural bridges are rated for far less, many for just 10, 15, or 20 tons. A loaded Caterpillar 797 weighs 687 short tons. That's 17 times more than the largest highway bridge limit. The concrete deck would crack, the steel beams would yield, the supports would buckle. And we know this isn't theoretical. In 2007, the I-35W bridge in Minneapolis collapsed during rush hour. 13 people died. 145 were injured. One contributing factor was the heavy load of construction materials concentrated above an already failing structural design. That bridge wasn't carrying anything close to a mining truck. It was carrying construction equipment and cars, and it still failed. A loaded mining truck doesn't just exceed a bridge's weight limit, it exceeds every weight limit in the entire highway bridge system. This is why mining companies don't even bother asking for permits. There is no permit, no escort, no special arrangement that lets a 687 short-ton vehicle cross a public bridge. The math simply doesn't allow it. And it's not just the bridges. Underneath every modern road runs an invisible system: water pipes, gas lines, sewer mains, fiber optic cables, electrical conduits, all designed to handle a specific maximum load above them. Drive a mining truck over that, and you don't just damage the road, you potentially rupture the city's nervous system buried below. Now let's talk about something more mundane, but just as decisive. The truck doesn't fit. A standard U.S. highway lane is 12 feet wide. A standard truck is 8.5 feet wide. That leaves about 3.5 feet of safety margin on either side. A Caterpillar 797 is 31 feet wide, almost 32 feet. That's nearly 3 full highway lanes, side by side, just to fit one truck. There is no highway anywhere in the world wide enough. The truck would crush the lane markers, scrape the guardrails on both sides, and physically cannot make a single turn. Its turning radius alone is over 100 feet, wider than most intersections. Tunnels? Impossible. Most highway tunnels are around 16 feet tall. The truck is 23 feet tall. Overpasses? It would hit the bottom of every single one. Even toll booths, traffic signals, road signs, and bridge railings sit lower than this truck's cabin. The truck wasn't built to share roads. It was built to be the road, on private mining property, with custom haul roads engineered specifically for its weight and width. So here's the question that almost nobody asks. If these trucks can never use public roads, how does the mining company even get one to the mine? You're about to find out the most absurd thing in modern logistics. They take it apart. When a Caterpillar 797 needs to move from the factory to a mine, or between mining sites, it cannot be driven on public roads. So Caterpillar ships it in pieces. The engine, frame, axles, and differential require 6 to 7 semi-trailer truckloads. The cab takes 1 semi-trailer. The 6 tires take 2 more. The dump body takes another 4. In total, one mining truck requires 12 to 13 separate semi-trucks to transport. Listen to that again. To move one mining truck, you need 13 normal trucks. And then, when those 13 trucks arrive at the mine, final assembly requires a team of 7 Caterpillar mechanics working in 3 shifts around the clock for 20 days. 20 days, round the clock, to put one truck back together. The dump body alone takes another 7 to 10 days to weld and attach after that. In 2015, a Dutch heavy transport company called Mammoth did something nobody had ever done before. They moved a fully assembled 797 in one piece across a Canadian highway. It required an entire engineering project, custom trailers, a route survey to map every single bridge and overpass, and special government permits at multiple levels. It was a world first. Moving one mining truck in one piece was so unusual that engineering publications covered it as international news. That's how locked out from public infrastructure these machines are. Moving one in one piece becomes a record event. Here's one last detail to put this in perspective: the tires. Each tire on a Caterpillar 797 stands over 13 feet tall. Each one weighs about 11,000 pounds, more than 3 Toyota Camrys. A single tire costs around $42,500. The truck has 6 of them. 3 of these tires fill an entire 18-wheeler. The pressure each one exerts on the ground is staggering, over 100 tons of force per wheel. That's not a load any normal pavement can handle. Asphalt would deform under it like soft clay. Concrete would crack within a single rotation. These tires aren't built like your car tires. They're built differently than the tires you know. They're designed to grip dirt and crushed rock at low speeds, deforming slowly under massive loads. Put them on smooth asphalt at highway speed, and the compound starts to degrade. The internal structure starts to fail. They overheat. They blow out. Mining tires aren't road tires. They're a completely different engineering category, built for a completely different world. So the next time someone asks why mining trucks aren't allowed on public roads, you'll know the real answer. It's not about traffic. It's not about size restrictions. It's about physics. A truck that weighs 687 short tons doesn't damage a road. It deletes it. The fourth power law guarantees one drive of one mining truck inflicts more pavement damage than thousands of normal vehicles combined. Every bridge would collapse under its weight. Every lane is too narrow. Every tunnel is too short. Every tire would crater the surface it touches. Every road you've ever driven on was designed to hold a maximum of 80,000 pounds. These machines weigh 17 times that. You've spent your entire life inside the design limits of regular trucks. You've just never seen the line where those limits end. The mining truck is what stands on the other side of that line. The road network you drive on and the road network these trucks operate on are two completely different worlds. Designed in parallel, built by separate engineers, operating on separate physics, and they were never, ever meant to touch.